Elon Musk, the visionary CEO of SpaceX, has one of the most ambitious goals in human history: making life multiplanetary. His plan to colonize Mars is not just about sending astronauts on a short-term mission. It's about building a self-sustaining human civilization on the red planet. This initiative involves several critical elements, including the development of advanced rockets, innovative methods of terraforming, interplanetary travel logistics, habitat construction, and sustainable resource management. If successful, Musk's plan could mark a turning point in human evolution. So in this video, we will discuss explaining Elon Musk's plan to colonize Mars. Spacecraft, the Starship launch system. At the heart of Musk's Mars colonization plan is the Starship launch system, a fully reusable two-stage spacecraft designed for deep space missions. Starship stands at an impressive 120 meters tall and has a diameter of 9 meters, making it the most powerful rocket ever built. It is powered by Raptor engines, which use liquid methane and liquid oxygen, methylox, as fuel. Unlike traditional rocket fuels, methane can be produced on Mars through the Sabatier process, allowing for on-site refueling and enabling Starship to return to Earth. This concept, known as in situ resource utilization, ISRU, is crucial for making Mars colonization financially viable. Starship is designed to be completely reusable, which drastically reduces launch costs compared to traditional expendable rockets. The spacecraft has a large payload capacity, capable of carrying up to 100 people per trip, along with all necessary equipment, habitats, and supplies. The ability to transport large amounts of cargo will be essential in constructing the first Martian settlements. Journey duration and landing mechanism. Reaching Mars is no easy feat, as the planet is an average of 225 million kilometers away from Earth. Depending on the alignment of the planets at the time of launch, the journey to Mars is expected to take between 80 to 150 days, with an average duration of 115 days. The key to successful Mars missions is launching during the optimal transfer window, which occurs approximately every 26 months when Earth and Mars are closest to each other. Upon arrival, Starship will have to survive Mars' thin atmosphere and land safely on the surface. The spacecraft will enter the Martian atmosphere at 27,000 kilometers per hour, 16,800 miles per hour, experiencing intense heat and pressure. Unlike traditional landers that rely on parachutes, Starship will perform a complex belly flop maneuver, where it descends horizontally to maximize atmospheric drag, slowing itself down before executing a final flip maneuver to land upright using its Raptor engines. This controlled landing system allows Starship to precisely place cargo and crew at designated landing sites, laying the foundation for future Martian cities. Terraforming Mars, the Nuke Mars concept. Mars presents numerous environmental challenges that make it inhospitable for humans. The planet has a thin atmosphere, consisting mostly of carbon dioxide, CO2, with very little oxygen and almost no protection from cosmic radiation. The surface temperatures on Mars can drop to as low as minus 125 degrees Celsius, minus 193 degrees Fahrenheit, in some regions, making it extremely difficult for humans to survive without protective habitats. To address these issues, Musk has proposed a controversial and radical idea: detonating nuclear bombs over the Martian poles to release trapped CO2 and water vapor into the atmosphere. The goal of this plan is to create a greenhouse effect, thickening the atmosphere and increasing surface temperatures to make Mars more Earth-like. However, this idea has faced significant skepticism from the scientific community, as many experts argue that Mars may not have enough trapped CO2 to achieve significant atmospheric change. Others have raised concerns about the long-term environmental and ethical implications of detonating nuclear weapons on another planet. While the Nuke Mars concept remains highly speculative, alternative terraforming ideas have been proposed, including creating artificial greenhouse gases to trap heat, building large-scale atmospheric processors to generate oxygen, deploying giant mirrors to reflect more sunlight onto the surface, releasing microbes or genetically engineered plants to slowly alter the environment. While these solutions are still in the early stages of research, they highlight the various approaches scientists are considering to make Mars more habitable in the distant future. Habitat pods and life support. Since Mars' surface is not currently suitable for human life, settlers will initially live in habitat pods, pressurized structures that provide oxygen, temperature control, and radiation shielding. These pods will be designed to withstand harsh conditions and will serve as both living spaces and operational centers for the first colonists. As the colony expands, Musk envisions the creation of transparent domes that will allow sunlight to pass through while maintaining a controlled atmosphere inside. These domes could serve as both living quarters and agricultural zones, helping settlers grow their own food. In addition to surface habitats, underground bases may be developed to provide natural protection from cosmic radiation, which poses a significant risk to long-term human habitation on Mars. Food production and energy generation. One of the biggest challenges for Martian colonists will be food production, as Mars lacks fertile soil and liquid water. To address this, settlers will use hydroponic and aeroponic farming methods, where plants grow in nutrient-rich water or mist rather than soil. These controlled environments will allow colonists to grow vegetables, fruits, and grains, ensuring a reliable and sustainable food supply. Water will be extracted from Martian subsurface ice, and advanced chemical processes will be used to convert CO2 into oxygen and methane, providing both breathable air and fuel for return missions. Energy will be generated using solar panels and small nuclear reactors, ensuring a stable power supply for habitats, greenhouses, and scientific operations. Timeline and future prospects. Musk has set an ambitious timeline for Mars colonization. The first uncrewed Starship missions are planned for 2026, with the first crewed missions expected by 2028. The long-term goal is to establish a self-sustaining Martian city, with plans to grow the colony to 1 million people by 2050. However, as of March 2025, SpaceX has encountered several technical setbacks. A recent Starship test flight ended in failure, with the rocket exploding shortly after liftoff in Texas. While these challenges highlight the difficulties of interplanetary travel, Musk remains committed to overcoming obstacles and pushing forward with his vision for a multi-planetary future. Recent developments. As of March 2025, SpaceX has encountered challenges in its Mars program. A recent test flight of the Starship spacecraft resulted in an explosion minutes after liftoff in Texas, marking the second failure for the program this year. The incident underscores the technical hurdles that remain in achieving Musk's vision for Mars colonization. While these plans are visionary, they face significant technical, ethical, and financial challenges. Nonetheless, they represent a bold step toward expanding human presence beyond Earth. Elon Musk's plan to colonize Mars represents one of the most ambitious projects in human history. His vision includes reusable spacecraft, self-sustaining habitats, innovative farming techniques, and even planetary-scale terraforming. While there are significant challenges ahead, SpaceX has already made groundbreaking progress in space travel, bringing humanity closer than ever to establishing a permanent presence on another planet. Even if Musk's timelines prove optimistic, his efforts have already revolutionized the way we think about space exploration. Whether Mars becomes our second home in the coming decades or centuries, one thing is certain: the journey to turn this vision into reality has already begun. Thank you guys for watching. If you want more videos like this, make sure to like the video and hit the subscribe button, and we'll see you in the next video.